All right, so last section we're going to look at is 4 or 5. We're going to look at it over 2 days, even though we're going to cover most of it today. Tomorrow we can kind of just review it and get ready for the test. So what we're looking at in 4.5 is lines of fit again. All right, so we talked about scatter plots in the last section, and in the homework, I had you guys take a problem and you drew in your own line of fit by hand, right? What we're going to look at today is how good of a job did you do, right? There's a way you can look at that line and say, yep, that's a really good line, or no, it's not as good. Right? And I'm going to show you what that is. All right, so we're basically analyzing how good of a line did you draw, okay, from the last section. So what we're going to look at is what's called a residual, right? And if you look at the picture, it shows basically what a residual is. So in your first bullet, you've got 3 blanks to fill in. It should say a residual, and then you have is the difference of, and the second blank is y value of a data point, and the corresponding y value on the line of fit. The line of fit is what you drew by hand. All right, so let's just look at this example on the right. So there's some points there. There's 4 of them. Honestly, I don't really think those points have much of a correlation. Right? To me, if I looked at this graph, I would say no correlation. Right? If you had a few more points, maybe you could tell. Now, this, I'm going to put these in red. That one and that one were the real data points that you got from a table. A table maybe like this one right here. So you graph these points, and I just put those 2 in red. And then you drew a line. This distance right here is how far away your line is from the actual point. Right? The further away your line is, the worse it is. Right? You want your line to be as close to the points as you can. Right? So if we go back to the homework, you could see right here, let me even zoom in a little bit. Right here, that distance that I just marked in green, that's a residual. Here's the actual data point from the table. Here's where the actual data point would be on my line. It's a little bit off. Not bad though. It's pretty close. The other ones, I couldn't even really draw residuals because these points are almost touching the line, so they're not good examples. But that one was a little bit off. So 2 kinds of residuals you can have are positive and negative. If your actual data point is below the line, below means it was a negative residual. If your actual data point is above your line, that's called a positive residual. So if I go back to this one real quick, just get rid of that green stuff. That data point is a little bit below the line. So that would be what's called a negative residual. But it's not that much. It's not even 1 block below. Just maybe almost like half a block. Okay? So that's called a negative residual. So a residual can either be positive, negative, or 0. Okay? And the only way you can tell is if you draw your line, look at the point, and look at your line. If the actual point is below the line, that's a negative residual. If it's above, that's positive. And remember, you want residuals to be as small as possible, right? The bigger the residual is, the worse your line is. That means your line is actually very far away from where the points are. And you don't want that. Okay, does everyone have those 2 bullets? All right. So I'm going to show you guys how we look at residuals, right? The way we're going to look at them, we're not going to take like a ruler and measure them. What we're going to do is we're going to make a picture. Okay? That's the easiest way to look at them. So when we make a scatter plot, that's just what it's going to be, an example that looks like that. You guys have this table down in example 1, and you already have it for example 2. So there's nothing you have to copy down here. Okay? That will also, I think it's already on the test for you. So all you're going to have to do is fill it in. These 2 rows in an actual problem are always filled in for you. Okay? Those 2 rows right there are like these 2 rows from a table. Right? So you're always going to be given the first 2 rows. You have to figure out these other rows. Right? And I'm going to show you guys how to do it. All right, so on the first bullet, the X and Y rows come from the problem. You don't have to fill anything in for the first 2. That's what that bullet's saying. All right. How do you get the Y value from the model? Okay. In this section, you're not going to have to guess what the line is. Like in the last section, we just kind of estimated it by hand. You guys aren't going to have to do that here. I'll tell you the model. Right? I'll basically say, okay, somebody made a scatter plot. They drew a line in by hand, and here's the equation they got. They figured out the slope. They figured out the y-intercept. You're not going to have to do that. You guys did that in last night's homework, right? And we did it in the last problem. We found a slope. You're not going to have to do it. So the y value from the model, you're going to find by plugging a number in. Okay? When we do an example, I'll show you. You're going to take an x value from your table, and you're going to plug it into a model that they give you. Like a model could be like y equals 2x plus 3. That's a model. So you're going to take an x value that they give you, and you're going to fill it into a formula. Right? And you'll get, we'll have a lot of practice with it. Now, the residual, very, very easy to find. All you have to do is subtract 2 numbers. You look at the y value from your table, you look at the y value you got from the model, and you figure out how far off are they. If the model's good, the residual should be almost 0, meaning that that line is super close to the point. If your residual starts to get big, that's not good. That means the model and the actual point are not that close. The idea is the model should be very, very, very close to the points. All right, so that's the third bullet. And then the fourth one, you guys just have a line, there's no bullet for it. After you've done these 3 steps, this entire table is going to be filled out. After these first 3 bullets, the left part of this is done. The last thing is to do that. Okay? You're going to draw a picture of your residuals, right? Picture, it's always easier to look at a picture if you're trying to explain something to someone than to just say a bunch of numbers. Right? Think of like a graph of data. Right? If you gave me a table with thousands of numbers in it and asked me to see the pattern, very, very difficult. But if you give me a picture, and the picture goes like this, well, then I can see a pattern. Okay, pictures are always easier. So that's why we're going to make a picture. And the picture is going to use 2 rows from this table. The x row, which is right here, comma, the residual row, which is right here. So you're going to take all the points in this row, all the points in the last row, and you're going to graph those as coordinates. And for today, that's pretty much the only thing we're doing by hand. That's it. That's the only type of problem you have in the notes today. Just that. There's nothing else. Okay? If we get to the calculator thing, that's not something you have to do by hand. The calculator does it for you as long as you know the buttons to press. All right, so this part, you don't have to write that down. I'm just reminding you of something I've already said. If a model is a good fit, if they drew the line in a pretty good way, then the residual value should be small. The bigger the residual value, the worse it is. Okay? And we're also looking to see, do we have about the same number of positive and negative residuals? Okay. Question? Yeah. So, if those were your points, and you drew a line like this, I would say that that's not a good line of fit. Every single point is below. So, that distance is a negative residual, so is that, that. I'm just measuring how far below the line all those points are. Okay? Those are all negative residuals. That's not good. Right? Let's put a line like this. All right? That's a negative residual, pretty small. That's a negative, that's a negative, that's a negative. And they're all pretty small. Right? That's a positive, that's a positive, that's a positive, that's a positive, because they were above the line. So you've got 1, 2, 3, 4 below. That's 4 negative residuals, and 4 above. And all the residuals are only like that long. That's pretty close to the line. So I would say that that's a good line of fit.
The other one up there.
I didn't draw the line long enough. So that's another negative residual, but that's about as even as you could get. 5 below, 4 above. There's an odd amount, so you're never going to get the same number above and below. Right? But that's what you kind of want to look for. The same number of negative and positive residuals. Okay, so let's try an example. So this y equals negative 2x plus 20. That's something that we found in the last section. You don't have to worry how to find it again. They're always going to give you this in the problem. That is your model. So the question we want to see is that a good model for this data? And the idea of a model, what you can do with it, is you've got sales in millions of dollars after a certain amount of weeks. If you have a good model that predicts this data, you could predict at week 10 what your sales would be. You could predict out to maybe week 30 what your sales would be. Okay? But that's only if you have a good model. Right? Same thing with like weather. Right? They make an equation that figures out what the weather is going to be. If it's a good equation and a good model, then what they predict the weather is going to be is what actually happens. If the equation that they use to predict the weather is a bad model, then they might say it's going to snow and it doesn't end up snowing, it rains. It's because the model they used to predict the weather wasn't good. Right? We're trying to look for a good model to predict this data. All right. So, on your notes, do you guys already have the first 2 rows filled in?
Yeah.
Okay. If you ever didn't, all you have to do is copy all the x's into the x row and put all the y's in the y row. Most of the time, that's going to be done for you. Okay. So your first step is to find the y value from the model. In our notes, what do the directions say to do for that? How do you find the y value from the model? Yeah, James? So, this bullet right here. So how does that bullet say to find the y value?
So plug X.
Yes, plug in x. That's what it says to do. plug in x. Which x? All of the x's, one at a time. Let's start with this one and fill it in right there. And you're going to do that for each number. Okay. What's negative 2 times, let's fill in 1. It's negative 2 times 1. Negative 2 plus 20. What's negative 2 plus 20? 18. So let's just look at that for a second. The actual y value from the table is 19. The model predicted 18. Did the model do a good job predicting it in that case? Yeah, it's pretty close. I mean, if the model predicted 4, I'd say, no, that's not that close. How close it was? Well, it was 1 away. We're going to write that down in a second. The residual is how far away that number is from that number. Right? But we'll do that after. Right. Now we plug in 2. What's negative 2 times 2? It's a negative times a positive. Negative 4 plus 20. What's negative 4 plus 20? 16. So the model predicts 16. The actual value is 15. Did the model do a good job there? Yeah, it's pretty good. This one was a little bit higher than what it should be. This one was a little bit lower. So that's good. Let's plug in 3. What's negative 2 times 3? Negative 6 plus 20. 14. Again, did a pretty good job. How good? We'll write it down in a second. Let's plug in 4. What's negative 2 times 4? And what's negative 8 plus 20? 12. Now we plug in 5. What's negative 2 times 5? Negative 10. What's negative 10 plus 20? 10. Eventually you start to kind of see the pattern here. Negative 2 times 6 is negative 12. What's negative 12 plus 20? 8. What's the next one going to be? 6, and the last one? 4. So those numbers in green are all predictions based on that equation. The numbers above it are what really happened. Now we're going to write down how far apart they are. That's the residual. In the guided notes, how did it say we find the residual? Do something minus something.
Row 2 minus row 1.
Row 2, yeah, minus what?
Row 3.
Row 3. Row 2 minus row 3. Okay, for each one of them. That's row 2, that's row 3. What's 19 minus 18? 1. So that's a residual that was 1 unit away, and it was 1 unit too high. Okay, 1 unit off. What about 15 minus 16? Negative 1. That's a residual that was 1 unit too low. Okay? But still, it's not bad. 1 unit off is pretty good. 13 minus 14. Negative 1. That's a residual that was 1 unit off and it was a little too low. 11 minus 12. Negative 1. All right, starting to get a little concerned here. We're having a lot of negative residuals. If every single one of them is negative from here on out, that's not good. That means your line's not in the middle of the points. It's too high. Negative residuals mean something like this. Every single point is lower than it should be. What's the residual here? 10 minus 10? 0. That means that the model predicted perfectly. That's like a point that's right on the line. Perfect. What's 8 minus 8? 0. That's another point that's perfect. 7 minus 6? 1. Okay, good. So we got another positive residual, which means now you've got a point that's above the line. So you got an above, below, 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 right on it, above. And what's 5 minus 4? 1. Above. So we got 3 aboves, we got 3 belows, and we got 2 perfect right on it. That's great. And all the residuals are 1 or smaller. That's exactly what you want. You don't want a residual of like 20. That means your point is way off the line. Okay, so now we got all our residuals. All right, what does the last step say that's not a bullet? X comma residual. So now what we're going to do is we're going to graph X comma residual. Right? So let me show you what the first one is going to be. You're going to take the number in the red box, comma, the other number in the red box. X comma residual. Okay. What's your first X value? 1. What's your first residual value? 1. 1, 1. We're going to graph that point. 1. All right, so this graph goes by, I think that's 0.5, negative 0.5, and that's 1. So 1, 1 is right there. I would probably just go by ones, but this graph's a little different, whatever. Okay, what's your second X value? 2. And what's your second residual? Negative 1. Okay, graph that one. 2, negative 1. What's your third X value? 3. What's your third residual? Negative 1. So 3, negative 1. What's your fourth X value? 4. What's your fourth residual? Negative 1. 4, negative 1. So when I start to look at that, I'm getting a little concerned because all the residuals are negative. Remember, if they're all negative, that means your line is too high because the points are all below. But we already know we got some more positive residuals coming out. So that's good. What's your fifth X value?
0.
Fifth X value?
5.
5. What's your fifth residual?
0.
0. Can't get a better residual than 0. 0 is perfect. Means it's right on the line. 5, 0. 6 X value? And the residual? 6, 0. You don't have to make this list. You just have to draw them, but it's easy for me if I have a list. 6, 0. 7th X value? 7th residual? 1. And then the 8th X value is 8. And what's the 8th residual? So 7, 1, 8, 1. 7, 1, 8, 1. 7, 1, 8, 1. So what you're looking at right here is a graph of your residuals. You've got 3 below, 3 above, and 2 right on. That's perfect. That's what you want to see if the residuals, if your model is good. Now, don't write this down, but here's an example that would be bad. If you had something like that, I would say that's a horrible model. Because first of all, you've got residuals that are huge. You've got residuals that are like 2, 3 units up. That's not good. And you've got like 10 residuals that are positive, and you only have 3 that are negative. That would be like having a line like this. You've got 10 points above it, and you only have like 3 below it. That's not good. You want the residuals to be balanced, positive and negative, and you want them to be close to 1. 1, 1.5, 2, that's okay. But if the residuals start to get like 3, 4, 5, no good. You don't want them that high. Yep. Okay, so any questions on that? Okay. So it's not a hard process, you just have to remember what to do. All right, let's look at example 2. It says the table below shows the age of an employee and the salary that they make. Now, the question here isn't, is there a connection between age and salary? They don't care about that. Maybe the older you are, the more money you make, if you have more experience. Like as a teacher, if you work at the same place longer, you make a lot more money than somebody who's just starting. But that's not really what they're looking at. They're saying, here's a model to predict the salary of somebody based on their age at this company. The question is that a good model? Right? So why would we want that? Well, if it's a good model, we could predict somebody who's 60 years old how much money they would make at the company using this formula. Right? If this is not a good model, it's like using a bad model to predict the weather. You might make a prediction, but what you predict isn't actually what happens. Right? So we're going to see if that's a good model for this data. All right. So on your table, does everybody have the X and Y rows already filled in?
Yeah.
Okay. So now what we have to do, we're going to probably need a calculator, is plug in, let's go back here, plug in each X value one at a time into your formula. Okay. What's the first X value? In our table. How much? 35. And we're going to plug it in right here. Yeah, I definitely need a calculator to do that. 0.2 times 35 plus 38. Okay. 45. Let's put that here. Okay. How was that prediction? Was that a good one? Maybe it should have been 42. The model predicted 45. So that's 3 off from what it should be. So let's see what happens. What's the next X value we plug in? 30 what?
37.
Yep. So 0.2 times 37. You're going to type that in a lot. Plus 38. Let's round that. It rounds down to 45. Was that a good prediction for the Y value? Yeah, that one was even better. That's only 1 away. That's what we're hoping for. What's the next X value? 40 what? 1. Plug 41 in for X. 0.2 times 41 plus 38. That's 46. Good prediction there?
Yeah.
Yeah, it should be 47. The model predicted 46. That's like they're saying, it's going to snow 10 inches and it snows 9 inches. They did a good job predicting. All right, what's the next X value? 43. 0.2 times 43 plus 38. That gives us 47. Not as good of a prediction there. That's 3 off. Right. How about Blake? What's my next X value?
45.
45. 0.2 times 45 plus 38. 47. Ooh, is that a good prediction? Oh, that one's bad. 47, 52, that's 5 off. This is not that good of a model so far, really. Every one of them is off kind of a lot. What's my next X value?
47.
47. 0.2 times 47 plus 38. We get 47 again. Not that good. Next X value? 53. 0.2 times 53 plus 38. We get 49 if we round it. That was a good one. You right on? Yeah.
Were we supposed to round?
Yeah, we're rounding.
Okay.
Yep, we're rounding. You can round it, that's fine. And what about 55? Let's see. 0.2 times 55 plus 38. Exactly 49. Okay, so now we have to find our residual. That's how far off the prediction was. How do we do that again? Row
2 minus 3. Subtract 5 minus the model.
Yep, 2 minus 3. What's 42 minus 45?
3.
Negative 3. How about 44 minus 45? Negative 1. 47 minus 46? 1. 50 minus 47? 52 minus 47? 51 minus 47? 49 minus 49? And 45 minus 49? Negative 4. Okay, so the last thing now is to make a graph. This number, comma, that number. So the first one is 35, comma, negative 3. So 35, I think the x-axis goes by 5s, the y-axis goes by 1s. If you wanted to fill those in, you could. What's my next point? I just did 35, negative 3. 37, negative 1. Okay, it doesn't have to be perfect, just kind of estimate. What's the next one? 41, 1. Okay, next one. 43, 3. Okay, better about there, I guess. What's the next one? 45, 5. These residuals are all over the place. This is not good. What's the next one?
47.
47. 4, I guess right about there, maybe. And then we've got 53, 0. That's a good one. And 55, negative 4. 55, negative 4. Okay, so how many positive residuals did we have?
4.
4. How many negatives?
3.
3. So, I mean, that part's balanced. You got 4 positives, you got 3 negatives, you got 1 right on it. So, that's pretty good. But are the residuals themselves small numbers? Not as small as the last one, right? When you make this graph, you want your residuals to kind of look like this. You want them very, very, very close. The further apart they are, that means your residuals were big. That's not good. All right? So the answer here, the equation, is the model a good fit? I would say no. The residuals are big. In the last problem, I would have said yes, the residuals were small. But this problem, they were kind of big. So any question on that? So on the test, you're going to have, I think, one of those, where the XY column is filled in. You got to do the Y value from the model, and you have to find the residual. And then you'll make that little chart. But this template is going to be on the test for you. So all you have to do is fill in the boxes. Okay, so any questions on that? All right. So what we did in section 4.4, when you guys had a set of points, maybe they looked like that, and you tried to put a line in, which I'd say that one's actually pretty good, 3 above, 4 below, that's what you're looking for. That's called a line of fit. Did I do any fancy calculations to draw that line? No, I just estimated it quick, by hand, the best I could. Well, on a graphing calculator, what we can do is tell the calculator all those points, and the calculator will do a fancy calculation and figure out the line with the best slope and the best y-intercept. And you don't have to find them. It'll find it for you. But it'll give you the best slope possible to get a line very close to your data that makes the residuals small. That's what the calculator tries to do. Make the residuals as small as it can. because points aren't always on a perfect line. You're not going to be able to make them 0, but the calculator will do the best job that it can. Way better than you could do by hand, right? So the process that the calculator uses to do that is called linear regression. And that gives you what's called not just a line of fit, but a line of best fit. It is the best possible line you could ever come up with. It's the best. It's as perfect of a line as you can get. And that's what I'm going to show you how to find on the calculator. Okay. So this is the line that's the best model for the data. Not an estimate, it's the best. Yep.
Why does the line need to be so clear?
Because if you want to make a prediction, you want your prediction to be accurate. So if I was going to go work for this company when I was going to be 60 years old, and they said, oh, here's a formula to predict how much money you'll make. Just plug in 60 for X and you can see what you'll make. If I did that and the formula said, oh, I'm going to make $70,000, but then I actually make $50,000, I'd be like, well, you told me this would predict how much money I would make. And they're like, well, yeah, but it's not that good of a prediction.
Wouldn't that be the numbers, not like the line?
Well, the line is made up of the numbers. So the line comes from the numbers. Another example would be like the formula for the weather. Like the formula for weather is way more complicated than that. But if they use a bad formula to predict the weather, and then people get all ready for like a foot of snow, and then it ends up raining, and there's no snow, people get annoyed because they're like, well, they predicted it was going to snow, and then it didn't happen, right? So you want to try to find a good equation to make your prediction. But like I said, weather is way, way more complicated than what we're doing. Same thing when they try to predict, like when there's like, usually in like August, September, when there's a hurricane, they try to predict where the hurricane is going to go. They're just using a model. They don't know exactly where it's going to go. They try to predict, so if you're in the path of the hurricane, you can evacuate if you need to or get ready, but that's why they need to have a good model. If it's a bad model and they say the hurricane's going to hit Texas, and then it ends up hitting Florida, that's kind of a big difference. They didn't do a good job predicting it. So that's why they use a computer to get the best model possible. And that's basically what we're doing. We're going to use a calculator, to get a good model. All right, so we'll go through one example. I'm just going to pass them out. You don't have to turn it on yet. Just, I'll show you everything from how to open it to turn it on and everything. Just be very careful passing them backwards because they're kind of slippery. You won't need it for homework, but you will for the test. So once you open the calculator, it's made so you can take the cover and put it right on the back. Okay? If you don't want to put the cover on the back, you can just put it off to the side. That doesn't really matter. Right? But if you do it right, you can just slide the calculator right into the cover.
I have one of these like replace me.
Those calculators do the same thing.
Yep. Okay, so first step. Okay, I need everybody to stay with me because if you get lost in the steps, you're going to be on a different screen and get confused. Okay, just press on. When you press on, you should just see your calculator blinking like that. Okay? If there's something on the screen because somebody used it to like do something like that, that doesn't matter. If you really want to get rid of it, you can press clear, but it doesn't matter if there's anything on the screen.
What if it doesn't?
It doesn't blink? Did anyone else press on and it didn't blink? Yeah, if the batteries are low, that's okay. Yeah, just try it. All right, it could be the batteries are low. I can change them. It's not a big deal. All right, so the first step, and this is on your guided notes, is you turn it on. Now, here's the part you might have to put on your reference sheet. Press stat, S-T-A-T. If you want to see where it is, it's where I'm pointing right here. It's this button. It says S-T-A-T. Anybody not find that button? Stat stands for statistics, right? That's what we're using. This is what we're doing today. This is a statistics lesson. When you press stat, you should see this screen. Options 1 through 5. Anybody not see that? If you didn't press anything else, the first option should already be highlighted. Option 1 says edit. Okay? So all you have to do is press the number 1, and now your screen should look like that. If you press option 1, your screen looks just like that. Okay? What this is it's a table. It's just like a table from our notes. X's are going to go in one column, Y's are going to go in the other. That's all that it is. Did anybody not get to this screen? Yep.
Wait, which one?
So you just press 1.
Oh, okay.
You press 1 to pick option 1. You're never going to have to pick any other option for this step. Okay. Now, the next step. It says type the X values from the problem, which are hidden under the calculator. I'll show you in a second. Type the X values into L1. L1 just means it's the first column, first list. L2 is the second list. So watch how I do it. Type the X values in, you type the number, and then you hit enter, and it moves you to the next line. So when you're done, your calculator screen is going to look exactly like that. Press the number 2, press enter. I'm going to do the Y's after. Press the number 3, press enter.
What?
Press the number 4, press enter.
It's so easy.
Press the number 5,
Was it just 1, 2, 3, 4, 5?
press yes.
Oh,
6, enter.
Just Olivia.
7,
shut up.
enter. Now, don't press anything else. If you did what I just did, you should have the numbers 1 through 7 right there. And it should look basically just like that. Anybody not able to get the numbers 1 through 7 there?
Scroll up and see all of them.
You have to scroll up. It's okay if it goes off the screen. It's because your screen's only so big. That's okay. Now, but everybody has those numbers.
Yes.
Okay, next thing you want to do, press the right arrow. The right arrow moves you to the next column. Okay? Was anybody not able to get over to the next column? If you pressed it too many times, you're going to go over too many columns. We don't want to do that. You want your cursor, that black box, to be right on L2, right below it. Does anybody's not look like that? Anybody stuck? Okay, now, it says in the second column, type the Y values. Type the Y values, and they're in the second column. Okay, so now we're going to do that. 9. Hit enter. 5. Hit enter. Now, let's say I made a mistake. 12. All right, or 1. Whoops, I meant to put in 13. All I have to do is press the up arrow. I can go back up and highlight the number, and then I can type 13, hit enter, and it fixed it. So if you type the wrong number, it's not a big deal. You can click up and fix it. Right? I'm going to type 11. I'm going to type 10. I'm going to type 11. Now I'm going to type this one wrong on purpose. 14. Whoops, I meant to put in 19. Press up. Just press 19. Hit enter, and it fixed it. So now you should have this exactly like it looks on mine. Anybody not able to get in those points? Okay, so as far as telling the calculator stuff, you're done. You've told the calculator everything it needs now to do what it has to do. You've given it all the X's, you've given it all the Y's. Okay? Everything is saved automatically. You don't have to press save or anything like that. It's saved as you do it. So now, it says after typing in all your data, press the stat button again. So press stat. Now you should be back at that screen. Now, if you went to, don't do this, just watch me. If you went to edit, you could go back and fix the numbers again. Okay? We're not going to edit because we've already typed them in. So press stat. And now it says press the right arrow to go to where it says calculate. Edit is when you need to type in stuff. Calculate is when you want the calculator to now do something. Okay? So press the right arrow to calculate. Now there's a lot of stuff here. the calculator can do all kinds of calculations, right? We want the calculator to do one thing, okay? Find a line. That's all we want it to do. So first, does anybody not see this menu? It starts with 1 var stats, which we're not even doing that. Right? So you press stat, right? And then you press the right arrow. So press stat, press the right arrow, and now you're at calc. Everybody's here?
I pressed the wrong button.
Press the wrong button. Stat, calc.
Oh yeah.
Okay, now you have to pick one of these options. This is the option that we're using. It's the only option that you're ever going to use on this calculator. It says lin reg. So I don't see it up here, so I have to scroll down until I find it. Yours could be off the screen. On my calculator, it's option 8. I don't know if it's the same on yours.
Yes, there's an 8 one though too.
All right. So you're right. It's 4.
Yeah, there is. There's one on 8.
Okay.
Stupid.
Be careful. Don't make the mistake I did. You want this one, ax plus b. Okay? It's like mx plus b. They don't use m on the calculator. They use a. But what do you think the a stands for? Slope. And what do you think the b stands for? Y-intercept. So once you highlight option 4, press enter. Okay? Now, I have an extra step on mine. I don't think yours is going to have the extra step.
Mr. Hager, I messed up.
How?
Okay. On your screen. Okay, I'll have to help you out. On your screen, you should see, guys, at the top, it should say lin reg ax plus b. It should basically just say this. You're not going to see this extra stuff. Does everybody say lin reg ax plus b at the top?
Yeah, mine says twice.
If you pressed it twice, it's because you did something twice. You didn't, but that's okay. But everybody says that. Now, press enter. When you press enter, I'm going to do it on mine, you should see something like that. A equals, B equals. How many people's does it say A equals 1.39?
I got this. No, mine says error valid.
Mine says syntax.
All right, I'll help you after.
857.
How many people got 5.57 for B? If you did it perfect. Now, the last step,
Big brain.
it says find a line. You found it, now write it down. That's the formula. Y equals AX plus B. What are they telling me to fill in for A?
1.39.
1.39. That's my slope. 1.39. Plus, what are they telling me to fill in for B?
5.57.
5.57.
How do you know to stop after the 9?
So that equation is the perfect equation for that data. You can't get any better. And if we were to graph these points by hand, there's no way you would get a slope that accurate, 1.39. I mean, we might get 1.1 or 2 or 2.5, but I mean, that's pretty accurate. Same with 5.57, okay? Nope, you don't have to graph that. Now, this part, next part, I just want you guys to watch. Okay? You don't need to press anything else on your calculator. Okay, watch what I'm going to do. I'm going to show you these as a scatter plot. You don't have to do this, just watch. Okay? Yep.
When you broke down the 1.39, it was a larger decimal, so how did you know to stop after the 9?
They'll usually tell you where to round, but you can go to 2 decimals. That's fine. So what I'm doing right now is I'm setting my calculator up so I can show you these points. Those points right there, you don't have to do this. That is a scatter plot of those points. Now, what I'm going to do is I'm going to type in that line and see how good it looks. Again, just watch.
What if you press graph?
1.39 plus 5.57. How good of a line does that look like?
What were we supposed to do?
You're just
We're
watching.
not supposed to do that.
You're just watching. How good of a line does that look? Pretty good, right? How many are above? How many below? How many right on it? One. So the calculator found.
Did I really? Yeah,
Okay.
I said, oh.
I'm just, guys, I'm showing you that the calculator found the most perfect line you could find. That's as good as a line as you're gonna get.
Let's go. Mine has not.
What's that, Steven?
Let's go.
Let's go where?
Let's go.
Well, I gotta help some people now because they got stuck.
No, like let's go like in private.
Oh, let's go, yeah. Yeah, so if you got stuck, just leave it where it is. I'm gonna come help you. Everybody else that didn't get stuck, I'm gonna give you guys the homework, okay? We're gonna practice another one of these tomorrow.
So what if you press graph?
Graph, you gotta do some other things to make it graph.
I'm gonna make that.
Okay.
Mine did that.
Why did it turn off?
I had to do about 4 or 5 steps to make this happen. I'm not gonna show you guys how to do this. I just want you guys to be able to do that.
I do that all the time. I'm still on.
Okay, so guys, tonight, homework. You're not gonna have a graphing one to practice because you don't have the calculator at home. You can't take it home. What we're gonna do is probably during the warm-up. Be very careful. That's a $100 calculator.
$100.
If it breaks, you buy it.
I would.
If it breaks tomorrow, you still buy it.
So you're telling me this piece of calculators is like $2,000?
Yes. So keep the calculator on your desk. If you got stuck, I'm gonna come help you. Everybody else, I'm gonna give you the homework.
It's called Joe.